Welcome to the Unit 6 CSA at Thomas Jefferson. This is Mr. Garrigus' class. Unit 6 CSA is next Thursday, Friday. Number 1, find the value of x that makes the triangle a right triangle. Okay, we have to be a right triangle, the value of x, let's label this capital C, little c, hypotenuse. This is going to be the shorter leg. We're going to call it A. So capital A diagonally across. We'll call this one B. So that's capital B. And now in order for it to be a right triangle, it has to fit into the Pythagorean theorem and be equal. So the Pythagorean theorem is A squared plus B squared equals C squared. Now we need a value of x that's going to fit that. So we're going to plug in for A, our value, 8 squared and 15 squared equals C squared. Now remember, it's easiest to solve for a missing hypotenuse, so this is one of the easier problems. 8 times 8 is 64. 15 times 15 is 225 equals C squared. I'm going to add 64 plus 225. I get 289. And now I have to take the square root of 289 and I get 17. So I'm going to draw a radical sign above the C squared, and that becomes C. Square root here, it's 17. X equals 17. No units are given, so you do not have to do the units. Triangle problem 2. Here we have a missing leg. We call it the long leg often. You know the short leg, and you know the hypotenuse. The first thing that we do every time that we start on these right triangles is we find the 90-degree angle, and we label that capital C, and the hypotenuse is little c. And then this looks like the shorter leg, so we're going to call that A, and this one capital A for the vertex, diagonally across. That leaves us with B here, and capital B there. We're still using the Pythagorean theorem. I'm not going to write Pythagorean theorem. I've already written it once. I'm just going to put A squared plus B squared equals C squared. We're going to put in for what we know. We have an A and we have a C. This time we're looking to find B. So it's one further step because I have to do a subtraction on both sides to solve it for B squared. So 13 squared plus B squared equals 22 squared. These are some larger numbers. I'm going to need to use a calculator. 13 squared, 169. And 22 squared is 484. B squared this is a variable term. This is a constant. These two things they can't interact together. The only way you're going to get B squared to be isolated by itself, we're going to subtract 169 from both sides. That eliminates the 169 on the left, and you're just left with a B squared. 484 minus 169 is 315. And then I take the radical of both sides. Okay, square root of 315 is 17.748. And here's a key here. They want you to round it to the nearest tenth. So we need to look at the digit to the right of the tenths place. So if I look on this calculator, tens, ones, tenths, I look to the right, the number to the right is a 4. I'm not going to round this up then. I'm going to leave it as 17.7. Really important there if you want to, the difference between maybe an A grade on your CSA and a B grade is that crucial rounding. Again, go to the digit you're needing to round for accuracy is the tenths. The number's a 7. To the right of it is a 4. So you only round up if it's a 5, 6, 7, 8, or 9. Problem 3. Now you're going to have this problem on your CSA. It gives you the side lengths for some triangles. We have to determine whether the side lengths make a right triangle. And when you take the test, you'll be dropping and dragging yeses or nos. For this study guide, we're just going to write the word yes or no in. Now, we apply the converse of the Pythagorean theorem. That says if I put a number in for a squared and b squared, if they are equal to c squared, if that's true, then we're going to write the word yes. So we'll just pop them in. Shortest is going to be A, middle length is B, the longest is C. So they all are, be careful you check that they're ordered from smallest to greatest because they might trick you sometimes. Let's do 5 squared plus 12 squared. Does that equal 13 squared? 25 plus 144 equals 169. 169 equals 169. Yes. Let's try 4, 6, 7. 4 squared plus 6 squared equals 7 squared. That's a question mark, sorry. Question mark. 16 plus 36 equals 49. 40, oh no, this is 52, I would think. 52 does not equal 49. So no. Let's try 20 squared. 20 squared plus 21 squared, does that equal 29 squared? Well, I know this is 400. 21 squared is 441. And 29 squared is 841. I get 841 equals 841. So yes. You can screen capture these while I'm working at home. For those of you in here, same thing. If you're on your computers, you can screen capture, but this will be all, these notes will all be put up. A rectangular board is 7 meters long and 4 meters wide. So it looks to me like they want to know the diagonal of the board. That's the question mark. So we find our right angle, capital C. Here's your little c. That's your hypotenuse. Then we have a little leg, a longer leg, and we're ready to roll. We're still using the Pythagorean Theorem. For 8th grade, we're not going to test on the distance formula, so that's kind of a relief. A squared plus B squared equals C squared. That's 4 squared plus 7 squared equals C squared. 16 plus 49 is C squared. That is 65, I believe, equals C squared. So we're going to have to use a calculator for that. Should be 8.1 because square root of 65 is slightly larger than square root of 64. Square root of 64 is 8. So yes, 8. Let's round it to the nearest tenth. 8.1. Again, look, you're looking at 0 for tenths, but the number to the right is a 6. So you need to round it up at that point. This has units, so you want to put meters in there. Now I've more carefully read it. It says they want it to the nearest whole meter, so I'm going to change it. It's to 8 meters. In this situation, I'm looking at, I want it in whole numbers, in whole meters. So I look to the number to the right, it's a 1. I'm not going to round it up. Problem 5. Leaning ladder, problem 1. This figure shows a ladder leaning up against a building. Okay, the ladder is placed against a vertical wall of the building. The base of the street here is 7 feet from the base of the building. The ladder reaches 24 feet up the wall from the base of the building. So this is important that they tell you it's a vertical wall and a flat street here, which makes a 90-degree angle. That's your capital C. Then you go across, the ladder is little c. This would be A, point A, B, point B. We have plenty to solve it now. We're solving it for C, because that's unknown. The question does say, how long is the ladder? So they want the length of the ladder here, C. A is 7. B is 24. We don't know C squared. I know 7 times 7 is 49, but I don't know 24 squared. I use a calculator, I get 576. I can add these numbers together, and I get 625. And then I need to take the square root of 625, which is 25 feet. So how long is the ladder? It's 25 feet. Problem 6. Pythagorean Theorem, leaning ladder. Okay, we have the same thing, but if you look at the picture or the drawing, now you're given the length of the ladder, the distance from the building. This would be more of a real life situation. It's more likely that you know how tall the ladder is and how far away it is from the building than you do how high up on the wall it's placed. Does that make sense? So this big old long 39-foot ladder is placed against the vertical wall, and the base of the ladder is 15 feet. Now we just need to mark up what we know. The 90-degree angle is going to be formed from the wall and the street. So that's your capital C, giving diagonally little c, the hypotenuse. This questionable length looks a lot longer than this 15 feet, so we'll call that A. Capital A we'll call the question mark B, and so that's capital B. So we're looking for B. We are going to use Pythagorean Theorem. A is 15. We don't know B, but we do know C. Okay, here we go with 15 squared, 225. But 39 squared, that's a big number. Let's clear the calculator and try 39 squared. Wow, 1,521. I'm going to subtract the 225 from both sides. It completely is gone on the left, and I'm left with b squared equals 1,296. How do I solve it for b? Take the radical square root of both sides. Square root 1296. Hey, it's a whole number, so that's nice. And it was measured in feet. Problem 7. A new highway was built outside of Tri-Town to relieve traffic on Route 1. So here's the city of Tri-Town. Here's Route 1. This street goes north and south, and this street goes east and west. So that would make a 90-degree angle. And they've already put a 90-degree angle in here. It was very nice of them to call that C. So the new highway is little c. Capital A here, which makes this little a. Capital B, little b. How many miles are saved by traveling on the new highway to get from point A to point B? So they want you to find the hypotenuse. We know how to do that. A squared plus B squared equals C squared. 48 squared plus 55 squared equals C squared. That's why it's so important to label your A, B's, and C's before you begin. Then you make way less errors. These numbers are very big. You're going to have to use your calculator. 48 squared is 2,304. 55 squared is 3,025. Okay, 2304. When I add those together, I get 5,329. If you want to put a comma in there, you can. But I just need to know what the square root of that is to get my length of C. Square root 5,329. Oh, it's a whole number, 73. So 73 miles. Okay, problem number 8. A right square pyramid is shown. Okay, so we have a little different of a drawing here that you have to think about where the right angle is formed on this pyramid. It gives you the height of the pyramid is 55. The distance from the center to the base here is 48 units. Notice that the right angle is here. It's the height is here, the height of the pyramid. And then this is like the base of the pyramid. So you need this outside. This is the height, but this is the hypotenuse along the outside here. This right here on the outside, formed from the inside, the right triangle. So let's call that A and B, and the hypotenuse, of course, is C. We know A and B. 48 squared, and B is 55 squared, C squared. Again, complicated here. 48 squared is 2304. 55 squared is 3025. I'm going to add those together and get 5,329. And then take the square root to find the length. 5,329. Oh, 73. I used the same numbers for both. 73. And finally, number 9. So here we have an interesting situation. We have what is described as a cone. The cone is comes to a single point at the top and comes down into a circle. So we're given some information here that the height of the cone is 10 and the distance across the circle is 6. And they said, find what is the slant height of the cone to the nearest tenth. Okay, well, the slant height is a little different than the height of the cone. The height of the cone is measured at a 90-degree angle from the base of the cone. So this is the height of the cone, not the slant height. If we build this triangle here, we want the slant, here's the 90-degree angle, so let's call that capital C. The slant height's the hypotenuse then. And then this base right here, it's 6 all the way across, so we only want half of that. We want 3. We'll call that A. And then the 10 will be the B. We'll change H to B. And now we have A, B, and C. 3 squared plus 10 squared equals C squared. 9 plus 100 equals C squared. 109 equals C squared. And I finally end up with the slant height of the cone. Radical 109 is 10.44. Here's that situation again. We're supposed to round to the nearest tenth, so we go to that location, look to the number to the right of that, which is less than 5, so we don't round up, we keep it at 10.4. 10.4 inches. And lastly, we've discussed this essential question a lot in the last 4 or 5 weeks. And it reads, what are some ways the Pythagorean theorem might be useful with triangles and in the real world? There are 2 ways that the Pythagorean theorem is useful. Okay, it's useful, 1, to find the distance between 2 points. And we actually spent a lot of time doing the distance formula on a coordinate plane. The other one is 2, to find the missing side of a right triangle. So that's a 2-pointer on the CSA. So if you want to get that, those people that really want to get that A+, you need both items in the answer. Okay. And with that, we're going to wrap it up. Study for your test. And when this is Ed puzzle, you got to get 70% or better correct, or a reset will happen.